I would like to show you how you can really trace such loop also on the Eclipse using Debugger. That's also a very important half for the picture. All right, let me switch back to Eclipse and let's do it. Okay, if you simply go back here, and then let's now try to trace it. As usual, we should set a breakpoint first. Since we're going to trace this particular test method, first of all, you want to make sure you don't have any other breakpoints for other methods. Otherwise, you may get just distracted. Okay, and then I'm simply just going to put maybe the line over here. So far, you can see the test case that we are developing only got 2 lines. But later on, once I introduce arrays, the test case might be extended a little bit, but it's still very understandable. Okay, but we'll see. Okay, so I put it here, and then so that means when I launch the debugger, I'm gonna pause right over here before I execute this line, right? No surprise. That's what we learned previously. All right, so now I'm gonna launch the debugger over here, but you can move, hold your mouse over here, and then it doesn't really show the class it's going to debug. So I would suggest, to be safe, you may just want to right-click on Test Utilities, and then you say debug as JUnit test. That'll be safer. Otherwise, it may not be launched. Click on that, and then it's going to switch to the debug perspective, right? By the way, you can see before I switch, you can see it's now really executing the 2B over here, but it's not going to complete it because we put a breakpoint. That's exactly why breakpoint can be so useful. You want to tell the computer, the Java runtime, you don't want to continue finishing the execution, but pause over there so I can examine further. All right, so I'm going to say switch to Java perspective. Okay, as usual, we got variables, we got also expressions. I'm going to worry about them in a moment. So now we are now in line number 31, right before we invoke the method over here, get sequence 2b, right? So what I would do is I'm going to say step into, and then as soon as I say that, let's predict what's going to happen, right? Remember from the paper, right? The understanding should be consistent. As soon as I say step into, 3, 5, and 20 will become ft, d, and also max. That's really important. All right, that's the main thing you want to predict. Well, if I say over here step into, what I will get is, you can see I got ft, I got d, and also I got max. So these are exactly the 3, 5, and 20 that I actually passed to call the methods. All right. Okay, so now what you can watch out for is we are now right before executing the result is assigned to empty string. So the result, you don't really see that under variable, not just yet. But if I say step over here, I'm going to see the result over here, empty string. Okay, you can see empty string. You can also look at the panel over here. Simply empty string wouldn't appear anything, just empty. What I want you to do is, you can see now, if I say step over, step over, step over, step over, right over here, right? Just pause at line 74. You can see the result so far is simply angle brackets. So that's really corresponding to what I did before. Remember the very initial string I got exactly over here. Simply quote and then angle brackets, right? That's what I did previously, right? I'm just trying to show you the connection. Whatever I'm doing on the iPad or on the paper is really consistent with how Java Debugger or Eclipse Debugger is implemented. All right, and then we can now predict what's going to happen. You can see all the values for all the variables. You got turn, you got sum, you got end, and etc. Okay, let me go on to expressions over here. Let me just remove all the previous expression over here just to avoid distraction. The state condition we got is turn over here less than or equal to max. All right, over here you can see it will be true, meaning that we should really go on for the very first iteration. So if I say step over here, I go into it. Okay. Now let me show you a little bit trick over here. Sometimes the body of the loop may contain many lines over here. We call it compound loop. You may not just want to step over, step over, step over, step over, step over all the way to the end. You may not need to. What you can do is you can now just put a new breakpoint exactly over here. Put it over here. Okay? And then what you can do is you want to basically jump from 75 into 79. That's what you want to do, right? As soon as I put a new breakpoint that happens later, in that case, I can now say step return over here. If I do that, it jumps all the way to 79. Okay? And then, so now if I say just step over once more, you can see now it finished executing it, and now we are back to determining if we should go for the second iteration. But let's pause a little bit. Let's see what happened here. If you go back to the variables, after the very first iteration, you can see very nice. Eclipse shows us what has been changed. You can see the first term 3 has been included in the result string, which is pretty good. And also the term right now has been 3 plus 5, which is 8, right? And also sum is 3 so far. And also n is actually we have processed 1 element so far in the sequence. You can double check this back to how I did it, how I did the tracing on the iPad. All right, so now we're now going to see whether we should actually go for the second iteration. But you can see turn less than or equal to max will simply just be true. Let me just be more explicit over here. Turn is 8. Used to be 3, remember? Before the first iteration. Max stayed the same, always just 20, right? It's the same. Okay, so now we are basically just going to go over all the iterations. Well, you can still do this trick to really say step out. You will again just move on. You will go all the way to 79 directly. I want to show you another trick over here. Okay, another trick would be I want to put a breakpoint over here 74. Double click. Okay, this one is a little bit advanced. I'll try to show you in other occasions as well, just the first time. Okay, is it possible to say, in general, you may have to go for many iterations until this state condition here will eventually get to false. If you state condition, if the state condition never gets to false, that means you got infinite loop. Because as soon as the state condition gets to false, you will exit from the loop, right? Remember, that's a principle for the while loop, and also similarly for the for loop. Now, let's say the sequence now is very short. Remember, how many iterations do we need to get before we get to the state condition here being false? We need to get 1, 2, 3, and 4. 4, right? 1, 2, 3, and 4. But what if we got a longer sequence that will get maybe 10 or maybe 20 elements long? In that case, we don't really want to just step over for 20 iterations. It may not be so wise to do so. But now, how can we make it a little bit smarter for the Eclipse, for the visualizer to get ahead for us? You think about debugger is like a slow motion, but now we want to somehow make the slow motion faster, if that makes sense. Okay, most importantly, you want to make sure you put a breakpoint exactly around this line for the state condition over here, right? And then right-click on this on the breakpoint. Right-click on that. If you right-click, and then I want you to really go to breakpoint properties. Okay, right-click on the breakpoint, and then go to breakpoint properties. That will be one very cool thing to do. If you do that over here, you can see over here, we are simply under line breakpoint, okay? You can see there's something called conditional. Click on that over here. So now we want to say, we want to break when the turn less than or equal to max becomes false. That's what we want to have, right? So there are different ways for you to write this. I'll show you a different way, okay? And now I will leave the one I most preferred. You can either say turn larger than max, right? This will be the negation of turn less than or equal to max. That'll be one way to go. Or you can say, this is what I most prefer. Turn less than or equal to max. If you just recall, turn less than or equal to max is the state condition. I want to say, I want to go all the way forward until it is not the case. All right? Let me just go there. So I can say, not the case, this. All right? You can see the exclamation mark is the logical negation over there, right? Okay, apply and close. Okay, I do that. You can see there would be some question mark over there. That's about the condition. All right. You can see the line 74 is about the conditional over here. All right. That's something new, but I really encourage you to really try things like this. Basically, not only that you can put a breakpoint, but I can say that I only want to break at this point if another condition is actually satisfied. In this case, I want to say I only want to break at this point over here if this state condition becomes false. Let's see. So let me just remove this point here because I don't want to pause any more intermediately inside the iteration. Let me remove this, and then I'm just going to say step return. Sorry. Okay. Only click, and then you can see now turn less than or equal to max has become false. That's why it stopped. All right. And then look at what the turn is currently. So we jump all the way from 8 to 23, which means all the previous iterations where the turn less than or equal to max evaluating true has been skipped, because this breakpoint here will only stop as we specify when this condition here is not the case, right? Hopefully, guys, you guys following what I'm trying to say here. It's a very advanced feature for a debugger, but I think you deserve to know. All right. I have every confidence that you can follow me. Otherwise, you can rewatch the video or get in touch with me. All right. All right. So that's that means if you now go back to the variables, you can see we are basically at the end of the loop, right? You can see 3, 8, 13, and 18. If you go back to the iPad over here, you can see this is basically the output we get as right after we exit from the loop. That's basically what we got, and then we're going to append ending angle brackets and also whatever average it is. And then if you look at other variables here, you can see the max remain the same, but for the sum, it's now 42, right? And also the number of items will be 4. These are exactly the values I showed to you over here. You can see 23 over here, and also 42, and also 4. Right? These are exactly the value I showed to you after the loop has been exit. This is something that I cannot do on the paper. In order for me to really keep track of all the iterations, I had to trace them line by line every time. However, in the debugger, it's been completely automated, so you can really specify the the breakpoint conditional, like what I did. Okay, rewatch the video to make sure you know how to do it. All right, so now we know that we can predict what's going to happen. Question for you. If at this point here, we know that this is false already, right? Turn less than or equal to max, the state condition is false. If I say step over, am I going to go into 75 or am I going to go outside the loop? It should be go to 81 because now state condition is no longer true. That means we're going to exit from the loop. If I say step over, exactly, okay? So now watch what's going to happen to the result over here. Okay, look at this. You can see at the moment, it's without the angle brackets, right? Closing one. If I say step over here, it's going to be 18 with the closing angle bracket, right? And then you can see, let's do a little bit of experiment over here. You can see this is basically the expression we would like to do, right? It's going to be like this. Copy just this part here about the casting. Go to expression here. Paste it, you'll see 42.0, exactly what I did in the iPad, right? And then we can say this one here divided by n, which will give you 10.5. All right, you can really experiment with yourself to confirm. All right. Now, if I say step over again, you can see the result now has become the expected result over here. If I click on that, you can see that's exactly the line we're expecting from the JUnit test. And then as soon as you say return the result, it's going to store the result into the value. Okay, let me just do one more. If I say step over, I'm going to switch back the context into this particular line, which means this part over here is the return value. As I illustrated before, as soon as I know that return result, which is this particular string over here. So that means I'm now switching back to the context where I call the method, because now the method returns. So this part here is simply just whatever the value it is for the result, which is this particular string. And then this is going to be stored back to the result for the JUnit test. Okay, let's try that. If I now say step over again, so now I'm just right before I try to execute it, right? You can see result, variable result is not declared just yet, right? However, as soon as I say step over, you will see the result is exactly the value over here. All right. You can see now we are in the context of test utilities. It's a different class. All right. And then assert equals is going to pass, right? Okay. And then we can now, you can simply just step return, step return, step return, step return, if you wish, but there's no need. You can simply just stop over here. You might be curious about what this really means. That simply means you kind of go into the interworkings for the JUnit test, but it should be hidden from you, so you don't have to worry. All right, let me just stop this over here, and then close this. Let's now switch back to the Java perspective. All right, that's about another very detailed tracing using the debugger, but what's really important is I showed you how you can specify conditional for a breakpoint. That's a very valuable tool for you to have. I'm pretty sure for any IDE you're using other than Eclipse, they also support something like this.